We're going to look at double replacement reactions a lot in this reactions lesson. And so I'm going to just show you some of the basics about them, and then we'll learn about how solutions work, and then we'll kind of put it together. But anyway, so a double replacement reaction, the reactants are aqueous. They are ionic compounds that are dissolved in water. I'm going to go ahead and figure out the charges that are on these. And the way that I know these charges is that, well, some of them I know from their position on the periodic table. Sodium is in the first column on the left on the periodic table, and that's my +1 column. Same for bromide, that's how I know. The NO3 is nitrate, and so if I look on a table of polyatomic ions, or if I have it memorized, I know its charge is -1. Silver is one you have to either have memorized or look up because it's a transition metal. But anyway, once I have the charges, I can predict the products. And what happens is that the positive part of one compound goes with the negative part of the other compound. Now I'm going to put the sodium compound first, but it doesn't matter which product you put first. So sodium is going to go with the negative part of the other, the nitrate. And I'm looking at these charges because I need to make sure that when I bring them over here, I'm making neutral compounds. And this is a neutral compound. It is +1 and -1. My other compound is going to have the silver. Notice their charges don't change. Silver is going to go with the negative part here, which is bromide. And again, this is another neutral compound, so I have a good compound, a good formula there. Okay, and then the next thing I'm going to do is put some state symbols on here. And how we decide this, we'll talk about a little bit later, but I'm just going to kind of tell you that here, this one is aqueous because it dissolves in water, and this one is a solid. It's because it does not dissolve in water, so it can't be aqueous. It will be a solid like in the bottom of your beaker or whatever. So this product is very important. We call that the precipitate. It's a solid, and it is water insoluble. Every double replacement reaction, you have to have a product that is a precipitate, a gas, or a molecular compound. One of the products has to be one of those. The most common molecular compound we will see is water. Most of ours will form a precipitate as one of the products, or a few will have water. Okay, this one, it forms a precipitate, so we call this a precipitation reaction. Okay, and this reaction was already balanced. Let's see what this looks like if you're in the lab or something. Those reactants that we just saw were aqueous, and when you have an ionic compound dissolved in water, the solution is clear or transparent. You can see right through it. Now these are like colorless. They could be clear blue or clear yellow solutions. They could have a color, but they would be clear. You could see through them. When you mix them together and they react, they get cloudy. And that cloudiness that you see is the solid precipitate that's forming as little specks throughout. Those little solid specks reflect light, so you no longer see through it. In this case, the precipitate compound must have been it has a color. It must be a yellow compound for this one. We're going to do a few more of predicting the products and see some different things that can happen. Again, the order of the products is not important. I could put the potassium compound first or the silver compound first. I'm going to go ahead and put the potassium compound first. So potassium is going to go front part of this one with that part of that one. It's going to go with nitrate. Again, if you do these charges, figure out the charges ahead of time, it kind of makes it easy over here. This is a very easy one because all of the ions are +1 or -1. And then my other product is going to have silver. The positive part is always in front, and it will go with chloride. And we won't predict the state symbols just yet. This one is balanced. Let's try one that is a little bit more interesting. Let's start by putting the charges up here. Barium's in the second column on the periodic table, so it's +2. First column. Again, this is acetate. It's polyatomic ion charge -1. This is sulfate. Okay, so then I'm going to put my products, and I'm going to put them down here. So barium with its +2 charge is going to go with the sulfate with a -2 charge. And then I check and see this is neutral, +2 and -2, so I don't need to change my subscripts. And my other product is going to be sodium. Positive part is always first. And it's going to go with acetate, which has a -1 charge. So again, this is already neutral. I don't need to change the subscripts here. Okay, let's talk about those subscripts and which ones I changed and why. So the first one is, why don't we keep this 2? In other words, over here, I did not do this to keep that 2. And why is that? Well, the reason that it was there over here was that we had a +2 charge there. This charge was needed with this barium to make this a neutral compound. So because it wasn't needed here, it wasn't needed because this is +1 and -1, so we didn't keep that 2. Okay, that is different than what we see for the 4. The 4 I'm talking about is this 4. We did keep that 4. We kept that 4 because that 4 is not from the charge. That 4 has to do with SO4 as a polyatomic ion. That's what sulfate is, and so that 4 stays. Again, this 2 doesn't stay because it was there because of the charge. If the subscript is there because it's part of the polyatomic ion, you do keep that. Okay, and the last thing to do is to balance this. And so on these, there's kind of just a pattern. You can start with whatever you see is not balanced. And I see right away sodium is not balanced, so I'll start with sodium. The other thing to know is that just like nothing changed charge, the polyatomic ions remain intact. In other words, I don't have to balance sulfur separately and then oxygen separately. Look how complicated it would be to balance oxygen because it's in 4 different places. I can balance acetates and I can balance sulfates as groups. So I'm just going to find something. I see sodium is not balanced, so I'll start with that. I have 2 sodiums here and just 1 here, so I'll put a 2 there. And then when I put this 2 here, that affected the acetate as well. So this has 2 acetates, and I come over here, I have 2 acetates. Let's go to barium now and check it. 1 barium, 1 barium, 1 sulfate, 1 sulfate, and so that's balanced.